Hello Geometry, here are some notes on similarity with transformations. So a similarity transformation is when you have some sort of composition but it includes a dilation. So it can be rigid motion with other aspects, but it also is going to include a dilation which is not a rigid motion. And so two geometric figures are going to be similar if and only if there's a similarity transformation. Remember that similar figures have the same shape but not necessarily the same size. We need to graph the pre-image. I'm going to do that in purple. This is a small little triangle. Make sure you label. Our first transformation I'm going to do in orange. That is a translation. And remember, you need to do your transformations in order. So I have to do this translation first. This translation is going to the right 5 with that +5 and up 1. So right 1, 2, 3, 4, 5 and up 1 for each point. Make sure you label. My next transformation is the dilation. I'm going to do that in green. It sometimes helps if you write out what your ordered pairs are. So for my new ordered pairs, my A prime is 1, 2. My B prime is 3, 3. And my C prime is 3, 2. With the dilation, you're taking those previous and most recent points and multiplying them by that scalar. So times 2. So my new A is going to be 2, 4. My new B is going to be 6, 6. And my new C is going to be 6, 4. So this is my new A, which I label with a double prime, my new B, and my new C. This is an example of a similarity transformation because it includes a dilation. This next one, I'm going to go ahead and plot my original in purple. Okay, we've got two transformations. The first one I'm going to do in orange. It's a reflection over the x-axis. Keep in mind that the x-axis is the horizontal axis, so I'm reflecting over that line. The h has nowhere to go, so your new h is going to be right on top of that other h. My F is 3 units away, so I'm going to count 3 units away on the other side of my line of reflection, which is the x-axis. And my G is 6 units away, so I'm going to count 6 units away on the other side of that x-axis and get my new G. Make sure you label, and label with the prime. I'm going to go ahead and write out what those ordered pairs are. So my new F is 0, 3. My new G is 6, 6. And my new H is. is actually the same as the old H, 3, 0. Now we're going to do a dilation, which is what the transformation I'm going to do in green. And for this dilation, it is multiplying by a scalar of 2/3. So you need to multiply every single xy value by 2/3. When I multiply 0 by 2/3, I still get 0. But 3 times 2/3, remember, if you're multiplying fractions, multiply the top number and divide the bottom number. So 3 times 2 on top would be 6, divided by 3 would be 2. When I multiply by 2/3 here, I'll do it off on the side. 6 times 2/3. Multiply by 2 first, so 6 times 2 is 12. Then divide by 3. 12 divided by 3 is 4. And so that's going to be 4, 4. And for the last one, 2/3 times 3 we already had above, and we got 2. And then 2/3 times 0 is still 0. So my new coordinates are going to be 0, 2, 2, 0, and 4, 4. Make sure you label double prime. Very good. All right. Down below we've got a couple of examples. We're supposed to describe the transformation. So it says, describe a similarity transformation that maps the trapezoid to the other trapezoid. So it can be doing more than one transformation. I'm first going to note that it is getting a lot smaller. It also seems to be reflecting. So my first one I'm going to say is that it's a reflection, and it's reflecting over the y-axis. If I were to just reflect over the y-axis, my new coordinates would be, let's see, something like this. So yes, it's reflecting over the y-axis, but it's somehow getting smaller as well. For the next one, I would recommend that you look at just one point. Just one point. I'm going to look at this point, which is 6, 3. That point becomes 2, 1. What does it take to get from 6, 3 to 2, 1? That's going to be a dilation, and it is getting smaller. It's dividing by 3. So that dilation is going to look like this. You have your xy, and then you're going to divide your xy by 3, which is the same as multiplying by 1/3. Okay. For the next one, it seems to do some sort of rotation. It's kind of moving around. I'm going to see if it's rotating 180 degrees. So I'm going to take my originals, and I'm going to rotate it 180 degrees. If I were to do that, and I were to put it upside down, and this would be counterclockwise. My new coordinates would be, let's see, my D would be at 2, -3. My E would be at -1, -4. My G would be at 0, -1, and my F would be at -4, 0. So when I go right side up, I'm going to just sketch those points in a light purple color and see if it's truly a rotation. So 2, -3, -1, -4, 0, -1, and -4, 0. When I connect those points, it does look like it's very close to my image. I now just need to translate it. So we do have the rotation. My second one is going to be this dilation. It needs to have one more movement that makes it a little bit smaller. Just take one point. So I'm going to focus on this point, which is -4, 0. That point turns into my U, which is -2, 0. How does it get from here to here? It's getting smaller. So it would be a dilation, and it's dividing by 2. So x, y, and we'd have 1/2 x and 1/2 y. Now, since we've done this whole problem, I've realized I've made a mistake, so I want you guys to look at this. I do agree that we have a rotation and a dilation, but I, shockingly, did not read the directions. Let's read these directions. It says, what does it take to get S, T, U, V, this little shape, to become the big shape? I did it backwards, which is why it's very important that we're reading the directions. So I'm going to start from scratch. We will still have a rotation of 180 degrees because even though we're starting with the other one, it's still going to rotate around the origin 180 degrees counterclockwise to get to that other shape. Okay, so let's start from scratch here. This is a little lesson for us all to read the directions. When we rotate 180 degrees and I look at the small shape, my U is at 2, 0. My T is at like 1/2, 2. My S is at like -1 and 1.5. And then my V is at 0.5. When I go ahead and plot that, this is the shape I'm getting, which is so close to what we have. It just needs to be multiplied. So we are going to have a dilation for our next one, but this time, if you're dilating and getting bigger, you're multiplying by a whole number or a number over 1. And so what is it going to take to get from, let's say, I'm going to pick a point, this one to this one. So what does it take to get from 2, 0 to 4, 0? Well, it's multiplying by 2, so I'm going to have x, y, and I'm going to multiply my x and y value by 2. Very good. Your guys' assignment is to work on this homework on big ideas. Let me know if you have any questions.